This is another gate problem, a practice problem on operational amplifiers, and the op-amp here is considered to be an ideal one, and we are interested in the output voltage V0. So with a problem like this, one has to check for whether there is presence of any voltage dividers or not, because if a voltage divider is present, it makes our job pretty easy. So just recall that a voltage divider is two, or it could be more than two series connected resistances, and let's say we have two resistances R1 and R2, and one end of it is supplied by Vp and the other end goes to ground, and we are interested in this midpoint voltage. So this is given by Vx, and Vx is equal to this resistance across which we are interested in finding the voltage. So this resistance R2 divided by R1 plus R2 multiplied by Vp. So keeping this picture in mind, if we search for a voltage divider in this circuit, we find that this bottom part of the network is that of a voltage divider. So you have a source here, which is actually the output voltage of the op-amp, which is V0. Then here is one resistance R1, there is another resistance R2, and this goes to ground. And note that no current can enter the input terminal of the op-amp. So basically this diagram and this one are equivalent. So this allows us to find out the value of the voltage at this node, and we call this voltage as Vx, and Vx is given by 10 kilo ohms divided by 10 kilo ohms plus 20 kilo ohms multiplied by V0. So this is equal to 1/3 of V0. Now, because the concept of virtual short exists here, therefore we know that voltage at this node must be equal to voltage at the other node of the two input terminals of the op-amp. Or in other words, if this is at Vx volts, the voltage at the inverting input terminals node will also be at Vx volts. Now, given that this is at Vx volts and Vx is equal to 1/3 of V0, and then we have V0 over at this end, and the difference between these two nodes are, this is equal to 6 volt. So basically what we can understand is that if the voltage at this node is V0 and the voltage at this node is 1/3 of V0, then V0 minus of 1/3 of V0 should be equal to 6 volts. And therefore simply plug in these values, and solving for it will lead to the output voltage being equal to 9 volts. So this sort of question basically tests whether we are aware of these voltage dividers, and if we are aware of them, we can easily find out the voltage at the inverting or the non-inverting input terminal nodes, and then go ahead with solving for the rest of the circuits.